Hi everyone. We just saw that video, those two quick videos of cams in general and what they do and how they do it and how to graph their motion, at least the beginnings of that. And then we saw some examples, just kind of fun examples of cams. And I'd also like to remind you of the cams we saw inside that boxer engine last time we met. So cams are used widely and they're used for turning rotational motion into linear motion. If you rotate this thing and there's say a wooden dowel on top of this, that dowel's motion will follow the shape of the cam. So as it rotates, it'd be nice and smooth, it wouldn't be changing position. But then when this part gets to the dowel, it would push it up, right? And then it would go back down as it rotates out of position again. So we're going to work on that. There's a bunch of different types of cams, and you can do customized cams if your motion is very customized. And there's snail cams out there, and circular cams, and elliptical cams, and this is a pear. Another very common cam is a pear cam. So I would like to try to draw this in on shape. Right? We could easily print these. They're very small, right? This thing is, gosh, I guess it's about an inch and a quarter, and then another. So this is 2.5 inches, like 3 inches tall. This whole thing is about 3 inches tall, right? So actually 3.5. That's right. So basically, the construction is like this. We're going to make a circle with a radius of 1.25 inches. We're going to make another circle with a radius of 1/2 inch. And if we put the 1/2 inch radius plus the 1.25 inch radius, that these two centers are the sum of the radii apart from each other. And so 1.25 plus 0.5 is 1.75. So we're going to put the centers of those two circles 1.75 inches apart. We're going to connect them with lines that are tangent to the circles. And then we are going to trim it up and clean up those lines and draw a center point there, a little square, 1/8 inch on a side, and extrude it to 1/8 inch. So let's get going and on shape. We are going to create a document. I think I will call this Pear Cam. Load up the workspace. And what we're going to do is keep that in view so I can see everything there. And I'm going to start a sketch on the front plane. I'm going to look right at it. I'm going to toggle off all these plane views by hitting the letter P. And that turns them all off. That's a little bit of a shortcut there. All right, so the first thing I'm going to do is grab my line tool, toggle it to construction line, and make it 1.75 inches long. 1.75 inches long. It wants to keep drawing, so I hit escape. That's the center of the big circle. That's the center of the small circle. So I grab my circle. I start creating the circle. And notice that what you have here is the diameter. That's the diameter symbol. But this says radius, right? So this number is twice that number, right? This number is 2.5 inches. That circle has a diameter of 2.5 inches or a radius of 1.25. This circle up here has a radius of 1/2 inch, so its diameter is twice that. It's 1 inch. Okay. We then go to our line tool and we put a line way up there, make it too long, put another one out here, make it too long, and go to your constraint tool and choose tangent constraint and make this line tangent to that circle and this line tangent to that circle. Same thing on this side. Tangent and tangent. Great. I go grab my scissors to trim it up. Trim that, that guy, and that one. I also don't need these inner parts of these circles anymore. Get rid of that, trim that, and trim that. And there's our cam, okay? The only thing left to do is put that little hole at the center. So let's make sure to do that. I'm just going to draw my little rectangle right here, my square. And it is, let's see, 1/8 of an inch on a side. So 0.125 tab, 0.125 tab. And I want that tiny little square to be centered right there at the origin. So I think what I'll do is zoom in, and I will go to, let me escape out of that tool, and choose my line, make it a construction line, and find the midpoint. There it is right there, to there. Escape, line, toggle to construction. Okay, so that's the center of our little square that we just drew, and I would like to put that right there. So I think what I'll do is just a coincident constraint. I'm trying to think if there's a better way to do it. There probably is, but I'm just going to do coincident, and if I make both of these lines, that line coincident with that one, it'll move it into the right place on the x-axis, and then that line also coincident with the center. Now it's in the right place on both axes, and I can finish my sketch. Okay, I'm going to zoom out. I'm going to zoom out and bring it in a little bit. Okay, good enough. And I'd like to extrude. And what I'd like to extrude first is this. Let's just see what happens. Extrude that 1/8 of an inch. Right, so 1/8, that's 0.125 inches. And since I chose just the outer part of this thing, I didn't choose the whole did not get extruded, right? When I selected this, I selected that material, but not the whole. So we are done here with this cam. There's the view of it, and I could go right ahead and do a drawing of it on the A paper, and let it load up for 1 second here. Oh, that's more than 1 second. Here it comes. I would like to insert that part. And there's the front view. Here's the ISO. We don't really need much here, just the material thickness. So maybe a top view or even a side view would do, right? But that's good. I'm going to click on that one and show shaded view. And you can go ahead and dimension this, right? You can just grab your dimension tools. Hey there. Grab your dimension tools and what's that? Let's see. It's got a radius of 1.25 inches. Oh, what's that curvature? It's got a radius of 1/2 an inch. And what's that thing down there? Oh, I didn't get it, did I? That's okay. How about from here to here? How about from here to here? What's that? Oops, that's an angular measurement. We don't want that. But so on and so forth. You can go in here and you can dimension all these different tools, all these different dimensions here. Right? 2-point linear dimension, point to point. Right, so here to here. That didn't take. That's okay. You can fiddle around with the dimensions, but the real build out was what's important here. I'm going to get this video online for you guys.